Well, I believe you have come across the word physical quantity when you talk about physics or even in chemistry. So, what exactly are physical quantities? I would say anything that can be measured. Anything that can be measured. Can be measured. So, what do you mean by anything that can be measured? Let's give an example. Say you want to find the height of your body. Say this is you, and you want to find the height of your body. Your height, which is some kind of length, it's a length. Your height is a physical quantity. It's not you that is a physical quantity. It's the height of your body. Or let's say you want to find the temperature of your body. Say your body temperature happens to be some 35 degrees Celsius or so. Then this is a physical quantity. The temperature is what you're measuring. It's a temperature that's a physical quantity, not you. So I can give an example. So height of a body is a physical quantity, or temperature of your body is also a physical quantity. You can use a thermometer to find it out. Or let's say you want to find the weight of your body. Your weight is also a physical quantity. So anything that can be measured is a physical quantity. It could be time. It could be time. What's the time now? You can say it's 9 a.m. It's been 15 minutes. Now you can say, so you can assign a numerical value. Every time you can assign a numerical value to something, it means that you can find it out. You can measure that using some kind of instrument. So time is a physical quantity. So likewise, you can give many example: area, force, and so on, velocity, speed, and so on. So if you find a moving car, or if you're sitting inside a car, you can look at the speedometer there, and you can find the speed. You can easily tell what is the speed of the body of that car at that very moment. So speed of a body can be measured, which is why you have speedometers. So anything that can be measured is a physical quantity. So there are many examples, and so on. It could be force, velocity, acceleration, weight, mass, time, momentum, and so on. So these are some of the examples. So I hope you get the idea. What do you mean by when someone asks you what is a physical quantity? So if physical quantities are the things that can be measured, then what are the things that cannot be measured? What are non-physical quantities? That's what I mean. What are non-physical quantities? Anything that cannot be measured. That includes our abstract feelings, like you can say love, you can say hate, you can say hunger. So these are all abstract feelings. This cannot be measured. You have no device or no instrument to find this out, to measure this out, to measure this, not measure this out. So love is not a physical quantity. You can say you love someone very much, or you can say you hate someone very much. You cannot assign a numerical value to it. We don't say I hate you 5, I hate you 8, I hate you 11. We don't say that. There is no numerical value assignment there, which is why we don't deal with this in sciences. There's no device to measure all these abstract feelings here. These are non-physical quantities, if I were to say. But luckily we don't deal with this here in sciences. You'll deal with that in I don't know, in socio, I don't know what, philosophy, I don't know, somewhere. That's equally important as well. So anyway, physical quantities. What are physical quantities? Anything that can be measured. Now the problem lies with the students not being able to understand the terms, all these physical quantities properly. If I ask you what is mass, if I ask you what is mass, and what is the difference between mass and weight? Mass is a physical quantity. You can measure mass in terms of kilogram. Weight is also a physical quantity. It can be measured, which is why you have your weighing machines. So weight is a physical quantity, mass is also a physical quantity. But what exactly are the differences? Are there differences? So there, student gets confused many of the times. I'm not talking about the not just class 11 12 students, even in their graduates as well. So you should know the terms very well. You should know how to define the terms very well, to the point that you know anything about it. Say for example, if I ask you what is mass, then pause this video and think for a moment. And what is weight? Likewise, there could be many examples. If I ask you what is distance, and what is displacement? What is displacement? You should be able to identify the differences here as a student of science. So then what is the difference between speed and velocity? What is the difference between speed and velocity? You should know all of this. Okay, so to begin with, let me start with distance and displacement, the easiest one of all. So when I say distance, so let's write. So our first target will be to know the difference between distance and displacement for this video. So distance, is distance a physical quantity? Yeah, distance is some kind of length. I'll tell you what distance is in a while. Then if I say a guy wants to move from point A to point B, a guy wants to move from point A to point B, taking this path. This is a path. Let me draw the diagram a little larger. Say this is how the guy wants to go from point A to point B. Maybe this is too big to write. Okay, so this is a guy, he wants to move from point A to point B, taking this path, and this is a path that he's moving. Okay, now imagine this path to be a thread. Thread means thread. So say you want to hold at this point, hold at these 2 points A and B, and try to straighten this out and see the length. Try to straighten this curve thing here, this path here, and try to straighten it out and see how long it is. That length will be the distance. Got it? I repeat, this is a path that the guy is traveling from point A to point B. My tongue is slipping. So if you try to straighten this out and see the length of this path, that gives you the length of this path. That length is called distance. So if I were to define distance, I would say total path, PATH, total path length that a body travels from one point to other. So let's assume some value here. Say this is, I don't know, 5 kilometers. The guy moves along this path, and if you straighten this path and see the length, it happens to be 5 kilometers. So the distance in this example is 5 kilometers. Then what exactly is displacement? When you say displacement, it is the shortest path length between 2 points. So the guy is traveling from point A to point B here, taking this path. In doing so, what is the shortest gap that he has covered from point A to point B? This is a gap. This is the shortest path length. And if I ask the guy to take the shortest path, maybe he'll go taking this path straight from point A to point B. So that will be the shortest path length between the points A and B, right? So this length. I'll just change this to a dotted line because this is not the exact path that the guy traveled in my example. So this is the shortest path between the points A and B. The starting point where the guy started, or sometimes we call that as the start or initial. Initial means starting, and this is a final point, or you can say the ending point. So the gap, in other words, you can say the gap, the length of the gap, the shortest path length between 2 points A and B, which are nothing but the final initial and the final points, is called your displacement. So this length here is your displacement. So now, as you can see from the diagram, this curved part here will be slightly longer than this straight one here. That's common sense. So maybe this is some, I don't know, 3 kilometers. So the displacement here in our example is 3 kilometers. So if I were to define, I will say shortest path length, shortest path length between 2 points, say initial and final. Got it? Let's keep the definition very short and very precise to make you understand. You can refer your textbooks for your technical textbooks, conventional definition. As for now, as for me, I'll try to make it as easy as possible so that you understand the concept. Got it? So that is the basic difference between distance and displacement. Now let's talk about distance even further. As you can see here, if I ask you, do we need direction when you talk about distance? When I say distance, it's all about how long the path is. Got it? Now, to reach the point B from A, it's not always necessary that you take this path only. There could be many other paths. Maybe like this. This is also one path to reach a point B, or this is another path. So it could be in any direction. You can take any path, you can take any style of path. It could be a zigzag, I don't know, that is up to you, as long as you reach the point B. So the length of that path, however you're traveling, the length of that path, the total length of that path, when you try to straighten it out, that will be the distance, total path length, as the definition says. So it needs no direction, it's all about how long the path is. We don't care. Say the length of the path along this is 5 kilometer, then the length of the same path starting from B to A is also 5 kilometers. We don't care which way we start, as long as we know the length of the path. Could be any path. Maybe this is also one path. Let's say, let me give you one more. Let me draw one more path here. Say to reach the point B, the guy travels like this again in the next example here. So if you can find the length of this path, that gives you the distance of this path. Got it? Total path length. So it needs no direction. When you talk about distance, it needs no direction. It's all about how long the path is, how long the length of the path is. So it requires no direction at all, which is why when you talk about physics, when you talk about any physical quantity, distance is a physical quantity, it's a length. So length is a physical quantity, right? I told you before. So distance requires no direction. It's all about how long the length of the path is, which is why we call this as scalar quantity. Any physical quantity which requires no direction is called a scalar quantity. Of course, we'll deal with this in the topic vector there as well. But for now, I just want you to be very familiar with every terms that you come across in physics. Almost every physical quantity, you should know how to identify between a vector and a scalar. And I'll try my best to explain that. Okay. Then that's one more. So distance is a scalar quantity. Okay, fine. Now let's finish distance first. Now here, if I ask you what is the distance between the point, what is the distance of this path? I mean, what is the length of this path? Or if I ask you what is the distance that the guy has traveled, means the guy has traveled along this path, right? So here the distance is 5. Did I say 5 kilometer or 5 meter? I forgot that. Anyway, let's write 5 kilometer. Maybe I mentioned 5 kilometers, right? So so the distance of this guy traveling along this path is, or you cannot say distance of this guy, let's say distance that the guy has traveled along this path is 5 kilometers. Got it? Now what about the distance of the same path? What about the length of the same path starting from B? I mean, if the guy were to start from the point B along the same path, it'll be still of the same length. It'll be still 5 kilometers. Let's take one example for you to understand. If I say Imphal to Ukhrul is roughly, it's not a straight line, it's not a straight path, it's roughly 80 to 90 kilometers from Imphal to Ukhrul. Then if I ask you what is the distance between Imphal and Ukhrul along this path, then you will say it's 80 kilometers. Then if I ask you again, what is the distance between Ukhrul and Imphal along this path again, you'll still say it's 80 kilometer. You never say it's minus 80 kilometer, right? Imphal to Ukhrul is 80 kilometer. Then Ukhrul to Imphal will also be 80 kilometer. Or I mean, assuming that it's along the same path. So we don't assign a negative sign when you talk about distance. We don't feel like talking about a negative displacement, distance. You never say, the distance from my home to market is minus 10 kilometer. You never do that, right? So when you talk about distance, it's all about how long the length of the path is. We don't need any negative there. So distance is always positive. So I'll write this as a point, always positive. It can never be negative. But the question is, can it be zero? What if the guy is not moving? What if a guy is just standing here, just like you? You're sitting there in your room and watching this video. You're not moving at all. So there, if something is not moving, then the distance can be zero. It means the body is at rest. I'll say can be zero, which means the body is at rest. Got it? Okay. Then let's talk about displacement based on on these what do we say, characteristics here. So what about displacement? You already know what is displacement, the shortest path length between 2 points. Okay, let me rub this off. So this, let me draw it again. This straight yellow line here is the displacement between the points A and B. Got it? Now I have a question here. Think about it. Do we need direction when you talk about displacement? Will it be a scalar or a vector? That is the question. Now, to give you an idea, I hope I can give you. Where is my Google Map? Google Earth. I hope. Nah. Anyway, I'll just draw a rough sketch here. Say this is our India map. Okay, and this is here. Our notice is here somewhere here, and my geography is horrible. So see this is our place here, Imphal, and you want to go from Imphal to somewhere, I don't know, Bangalore. Say this is Bangalore, and say you're the pilot and you'll be flying a plane, and if I ask you to take, this is Imphal, if I ask you to take the shortest path possible, means you have to go straight, right? You have to go straight and reach Bangalore here. Now if your plane is parked like this, now what should be the color of the plane? Let's say and this is a plane, and I'm not good with my diagram. I hope it looks like a plane. So now if I ask you to take the shortest path possible, if a plane is turned, my bad, if a plane is turned towards this direction, how will you take the shortest path? Got it? So this is the Imphal, the Manipur here. Imphal is the starting point. So from the starting point, you have to turn your face towards the ending point. Where you want to go? Oh, the guy, you want to go towards Bangalore. So you have to turn your plane towards Bangalore, straight, and go fly straight, passing through any obstacle. This is how you reach Bangalore. Straight, taking the displacement, right? This is the shortest path possible. I mean, if I ask you not to take the shortest path, maybe you can fly around Delhi and come back and reach here. But that is not the shortest path here. So if I ask you to take the shortest path, meaning the displacement, then you have to go turn your face towards where you want to go. You want to go to Bangalore, so turn the plane towards the Bangalore's direction, and you fly straight, passing through any obstacle. Theoretically, practically it's not possible. So this is how you go, right? So when you talk about displacement, meaning when you talk about taking the shortest path, you have to know where you want to go. I mean, if you want to go, say this is your home, and this is you, and if you're facing towards this side, then how will you ever take the shortest path possible? Got it? So if you want to take the shortest path possible, you should know where you want to reach, and turn your face towards that destination point and go straight, passing through any obstacle. So when you talk about displacement, there's a sense of direction. There has to be some kind of direction. At least just think about it. You have to know where you want to reach, then you have to go straight. So you have to turn your face towards that direction. So when you talk about displacement, there's a sense of direction. So it is a vector quantity. Any physical quantity which has direction, most probably is a vector quantity. Now I just said most probably. Why? Not now. Maybe in the next, future videos, I'll tell you why. Not every physical quantity that has direction is a vector quantity. Example: electric current. Although it seems like it has direction, it does have direction, but still we don't consider electric current as a vector quantity, or something like pressure as well. That we'll discuss later on. For now, let's just know that displacement is a vector quantity. Okay. So can distance be not distance? Oh, let's compare this point. So can displacement be zero? No doubt, it can be zero. Can it be positive? No doubt, it can be positive. Can it be negative? It can be negative. Now let's talk about why and how displacement can be both positive and negative. So for that, let me give you a reference. I hope my battery is, it's 9%. Me and my battery. There's always a war between me and my battery. This is east, west, north, south. To give you the perspective of direction, let's mark it here, and a guy wants to move from this point. Say this is a starting point, and he wants to move. A guy is moving towards east. Got it? And he has moved in a straight line. Okay, and he has come here. This is a guy moving along this direction. Say this gap here is, I don't know, say it's 5 kilometer. Got it? And another guy is moving. Let me draw it somewhere around here so that I can I hope my running man looks like a running man. Okay, let me duplicate this here. Okay, so another guy starts from this point and moves along this direction, and the gap is still, again, it's still 5 kilometer. So this is also 5 kilometer. Now the question is, okay, he's moving along this. So as you can see, the white guy is moving along this direction, along east, according to our direction reference here. This guy, the white one, is moving along east. And what is the distance? It's straight, right? The distance is 5 kilometer. What is the displacement? Also 5 kilometer. But when you talk about displacement, you should have a direction, a sense of direction is there. So if I ask you, what is the displacement of the guy, the white guy here, I'll say the ISP for short. Displacement of the guy, the white one, is 5 kilometer moving along east. Here if I ask you what is the distance, distance is how long the path is. Luckily here the guy is going straight, so the value of the distance and displacement will be same, so it's also 5 kilometer. What about the yellow one here? If I ask you what is the displacement of this yellow guy here, it will be also 5. The value is still 5 kilometer, but he's moving along west, so it's 5 kilometer west. Then if I ask you what is the distance of this guy here, then you can say it's still 5. Distance is all about the length. How long is this? It's 5 kilometer, so it's also again 5 kilometer. As you can see, the distances are same, but when you talk about displacement, one is moving along east and one is moving along west. In physics, we hardly use this east-west notation. This is not geography, so we don't write east and west when you talk about physics. It's rather mathematical. So instead of writing east and west, we assign a positive and negative. If I take this east side as positive, then the opposite will be taken as negative. I mean, the west will be taken negative, and vice versa. In short, if you take the west as positive, take east as negative, which is opposite to west. If you take east as positive, take this as negative, and vice versa. I mean, that is up to you. Whichever way you want, that is up to you. You can take either way. So for the sake of convenience here, normally we have a habit of taking the right side as positive in maths and all. So I'll just say the east as positive. You can take whichever way you like. So if I say it's plus on east side, then this will be taken as negative. So in other words, you can write the displacement like this. So let me just move this a little bit up. So I can also write this as, I have taken east as positive, so I can say it's plus 5 kilometer here. Let me move this down so that I don't interfere with my notes. So then I can say this is, okay, minus 5 kilometer. Got it? The minus sign here does not mean that it's less than 0. Not like your math. In maths, we say this is the origin 0, this is 1, this is minus 1, this is 2, this is minus 2. If I say minus 2, we consider minus 2 to be less than 0, right? I don't mean that. Now here, the negative sign here simply means that it's opposite to this guy here. Got it? So displacement can be negative, but the negative sign does not mean that the value is less than 0. We don't mean that. It's all about indicating the sense of direction. It means if this is negative, there must be something positive, which is this here. So this displacement is opposite to this displacement. That is the meaning of the negative sign here. Got it? It simply means it's opposite to some other direction. Got it? Now, there was a time when a student asked me, sir, what about if there is a guy, let's say there's only one guy moving in one direction. Say there's one guy, this guy is moving along this direction, and it has moved this far, and say this is, I don't know, the gap is 3 kilometer. Got it? Here, and if you want, you can add this east, west, north, south notation here. As you can see here, what is the displacement of the guy? Is moving along this direction. You can say it's 3 kilometer. Here I can assign east if I want, but here, will you assign, is there any way to add a negative sign here? No. Why? Because there's only one story here. There's no other guy moving along this direction. The story ends here. It's all about this guy moving in this one direction. There's no other comparison. There's no other direction to compare, right? There's no other guy, or there is no other direction involved in the story here. There's only this guy moving along this direction. Here we just assign positive here. Don't add a negative here when there's only one direction in the story. Okay, so when there's one, there are two or more directions, you can assign accordingly which one is opposite to the other one. You can take one positive, one negative. That is the meaning. Got it? So displacement can be positive and as well as negative as well. Now the next question is, can it be zero? What if the guy is standing, not moving at all? If the guy is not moving at all, obviously the distance will be zero, displacement will also be zero. Got it? But the question remains, what if the guy is moving from a point, say X, and he goes along this path, then he comes back to the same point? If that is the case, what will be your displacement value here in this case? So think about it. When we define displacement, we need 2 points, where you start, also called the initial, and where you end, also called the final. So it's a gap between the initial point and the final point. This gap gives you your displacement here. How long is this gap? How long is this line? This yellow line here gives you the displacement between the points, these 2 points here. But what if the gap becomes closer? What if the final point comes nearer? Then this will be the displacement now. This will be much lesser than before, right? What if the gap becomes even closer? What if the gap is even closer? Then the displacement will be even less, as you can see, which is very, very common sense. What if the gap overlaps? What if this final point, let me draw with a different color here. What if the final point and the initial point, they overlap? Which means there is no gap at all. If there is no gap, the displacement will be zero. I hope you get the idea. In short, if you start from a point, let's say this is your home, and this is your market, say this is the bazaar, and this is a path, and you start from this point, your home, then you go to the bazaar, and you come back and sit at the same point. You come back to the same point. However you go, I don't know, however path you take, maybe you came along this path and you come back to the same point. If so, the displacement will be zero. If the initial point and the final point are same, if you come back to the same starting point, the displacement will always be zero, because there is no more gap between the 2 points. But the distance will not be zero. I mean, look at this example here. Say the guy is running along this point, along this path. The guy is running along this path. So how long is this path will be the distance, no doubt. But what is the displacement here? He comes back to the same starting point, so the displacement here will be zero. So I hope you get the idea. When you talk about displacement being zero, there are 2 conditions. One, the object is at rest, so it can be zero. So it can be zero. All right, it can be zero. Got it? So when it's zero, there are 2 conditions. One, the body is at rest, or the body starts from a point and comes back to the same point. Got it? And it can be positive. It can be positive as well as negative. But the negative here does not mean that it's less. The negative displacement value does not mean that it's less than zero. It simply means that it's opposite to some other direction. These are some of the comparisons that you can see when you talk about distance and displacement. Of course, I want to dive a little more here. That I'll do in the next video. And if you have any doubt, you can still ask me in the group. I don't know how you're going to reach me, but maybe in the group or through comments. I don't know. Give it a try. I hope you have learned some. See you in the next video.